This is Gregory Fleischer from Fishnet Security. He is a senior security consultant in their application security practice. And believe it or not, and I didn't at first, I had to actually question this, in his spare time, he researches and worries about web AppSec. So with some great applause, I'd like to welcome Gregory to the stage and help him understand he needs another hobby.
Definitely. Hey, everybody.
You are in web tracking for you. If you are not supposed to be in web tracking for you, well, you should probably get up and go. Please make sure that you do fill out your speaker evaluation forms. As a former Black Hat speaker, I will tell you that not getting feedback made me cry. Gregory has already had issues with his AV. Do you really want to make him cry? No.
No. Please don't.
Have a great hour.
Oh, thank you. What's left of it anyway. Oh, how's everybody doing today? Pretty good? So, while I get set up here and get figured out what's going on, just a quick show of hands so I get an idea kind of what everybody's into. How many people have used the collusion in either Chrome or Firefox, the collusion plugin? So you guys kind of have some sense of what web tracking is and how it all plays out. So this talk's kind of a combination privacy talk and browser security. So there's a little bit of overlap. So it's probably a little technical. I didn't want to have another one of these talks where somebody gets up here and says, oh, here's how all these people on the internet are tracking you. And here's what you can do about it. Because actually there's not much you can do about it. So what I want to give you is empower you to track people. You know, if you have a website and you're interested in who's coming there and you want to track them over time, you know, maybe they're malicious users, I want to give you kind of the tools to do that. So just a brief bit of an introduction. I'm Gregory Fleischer, a senior security consultant at Fishnet Security. I'm in the application security practice, as was mentioned. So I do a lot of application assessments. I see a lot of web code. I see a lot of application traffic. So I have kind of an idea of how all of this fits together, especially at the kind of enterprise level, you know, looking at code that's handling bank transactions and that sort of thing. About 3 years ago, actually 3 years ago, almost exactly, at DEF CON, I gave a presentation called Attacking Tor at the Application Layer. And a lot of the research I did then was very kind of deep dive down that stack. It was Firefox and Tor. And for people who aren't aware, Tor is the onion router that does, you know, anonymity online. So I came across, I would say they're not really vulnerabilities and they're not really features. So some people call them featureabilities or vultures or something along those lines. And I went through and I've been collecting these now for probably 4 years. All these different little tricks to install persistent tracking identifiers or do fingerprinting. And some of this topic has been covered before, but I really wanted to do a deep dive and go through each of, you know, the individual browsers and individual plugins and really get deep and see what I could do. So here's a standard disclaimer, and these are kind of the two responses I usually get. It's like, why do you hate blank? Like, why do you hate this vendor? Why do you hate this open source project or whatever? And then I get this other response, which is, hey, I need help tracking these users. So those are kind of the two responses I've gotten when I've gone through these types of presentations. All right, so what are some reasons for tracking users? There's the very traditional reason, which is metrics and analytics. Especially if you're advertising and you want to monetize users' behavioral characteristics to serve them better content, or maybe you want to track users to prevent click fraud. Those are all legitimate ways to identify users. The same with security, you know, track them. But maybe you want to monitor for malicious users, bad actors and attackers. You know, if you stand a website up, how do you know what people's intentions are that are coming there? You know, some of them are probably bad guys and they're probably out to get you. So part of tracking is a very legitimate purpose of searching for suspicious behavior. So what are the types of tracking? First party tracking is essentially when you go visit a website and they install a cookie, let's say it's like a session cookie or something along those lines, to track your activities on that site, to identify you, to give you personalization. The third-party trackers are the ones that are the behavioral advertising or the social networkers, working that have plugins and badges. Put this little LinkedIn thing on your website or this Google Plus, and people click on it, and so they are tracking you as you move across the web. And the people that have used the collusion extensions have seen all that. You get these fancy graphs, and it really ultimately though doesn't do you any good. And then there's this kind of controversy about analytics. And is it counting? Is it tracking? What's going on there? So I wanted to do for my first demo, and tempting the demo gods here, guys, is try and show you how pervasive tracking is. So, and I don't have anything against Microsoft. I just wanted to have all of these in one specific site. Okay. This was all set up to go great before, so bear with me. Okay. So I have Collusion installed, and I just opened Chrome. Okay, that's kind of the what's going on there. And if you look, there's this request that goes out to api.mixpanel.com with this track and data equals all this garbage. Now, you may wonder what all that is, and I'll show you here in a second. Now I'm just running all this traffic through Burp so you can kind of see it. And this is base64 encoded. And that's probably kind of tiny. Format that. And so what this is a request from the Collusion extension going out to some API tracking site. So basically, the extension you installed to track trackers is tracking you. So it's like tracking the trackers, trackers tracking. Is that not pervasive? Even the plugins that are supposed to show you, oh, you're being tracked, are tracking you as you use them. I mean, it's just great. It's so pervasive that there's no way to get away from it. So there was our demo. That worked, by the way. Woohoo! So what are some alternative ways of tracking? And this is kind of the corporate enterprise environment where you have traffic inspection that you're applying to people as they surf the internet, and you probably are routing them through some sort of corporate proxy. This also can occur at the provider and host ISP levels. Maybe they want to track who's let's say downloading illegal content. There was going to be that 6 strikes law or whatever to say, oh, you're going to get banned if you download those illegal files. And the other way to do it is through content modification. Instead of examining the request, you actually modify the responses that come back. And you inject your code in there. And if you've been to many hotels, you've probably seen sometimes they'll go ahead and inject content into your pages that you're viewing over the hotel Wi-Fi connection or wired connection. And so you can do the same thing by injecting web bugs and tracking code. So here are 3 key concepts that we're going to talk about with tracking. There's fingerprinting, which is to go through and do an examination of, kind of collect facts about the web browser or the traffic. There's tracking, which you can think of as installing some sort of persistent identifier on the user's computer through their web browser. Unmasking, which is to go and try and find out what their, let's say, IP address is or operating system characteristics. And these aren't really mutually exclusive. They can kind of reinforce each other, and we can do comparisons to see if we can correlate any discrepancies. So fingerprinting. The goal of fingerprinting is basically to calculate a unique fingerprint based on the user's web browser characteristics or OS characteristics. And this can be much more resilient to privacy actions that users take. If they dump their cookies or if they clear their cache, it's very hard to change the characteristics of your web browser, how it behaves and how it acts. And you can break this down a little further into passive and active fingerprinting. And this is further complicated by if you have plugins and extensions installed, and if we can identify and examine those. So with passive fingerprinting, information is captured passively, and we can use this data basically to group people into broad categories because there's not fine-grained data that can be derived from this. You know, there are some people that say, oh, well, you can be tracked just by your user agent alone. Unless you have some sort of unique identifier embedded in your user agent, that's highly unlikely. You know, there's still a fairly wide variety of people on the internet that have similar characteristics, if not the same. So we can only put people into certain silos. You know, we aren't going to get a perfect match just based on your user agent. And another problem with this is that information is very easy to fake and hide and obscure. You know, there's proxies and plugins out there that can modify your user agent to make your Firefox browser claim it's Internet Explorer. So that's a very big limitation of passive fingerprinting. And so some of the types of information that is available is the user agent string and the order of request headers. But there's also intrinsic components of your web browser that can be used. So let's say when you make an anonymous FTP request, each of the various web browsers sends a username in that anonymous FTP request, and you can differentiate those. So that's going to be something that's not really a web browser. That you can't really change that because it's part of the web browser itself. And then you can look at how requests are handled. There's a content site policy, which is a way to report like cross-site scripting violations. Image types, those, you know, you can test if the browser supports different image types. These used to be a bigger deal, but as time's gone on and all the browsers are catching up to supporting the major standards. And then even the HTTPS handshake can be profiled. You know, there's different cipher suites and supported extensions. And you can get oftentimes the timestamp of the client machine when it makes the connection. So that can be some very interesting content that's available to you. So passive fingerprinting with plugins, and plugins themselves have additional characteristics when they make requests. They might have a custom user agent. They might inject different header information. So like there's this Java request was made from a Linux 2.6388 generic machine, which is way more detailed than probably the Firefox browser that came from. That's way more detailed. Flash, on Internet Explorer, you're going to see X-Flash versions being sent. And, you know, you can get very, very fine-grained information from that. And active fingerprinting is different. That's where you're actually running JavaScript code in the web browser. And you know, you can either do that directly through JavaScript, embed CSS, and it's much harder to fake or hide because of the direct interaction that you're having with the web browser. You know, you're interrogating it as it's running. And there are actually modern libraries like the Modernizer library that does this to provide you with the ability to target robustly feature sets. So what are some of the standard items? Navigator information and screen resolution. This is kind of typical analytics type of information that you're going to get, date and time zone, installed plugins and fonts. Browser extensions, you know, specifically for Chrome and Firefox, there's a very robust development community around creating add-ons and extensions. And when they do that, people want to make it easy for you. So they offer certain frameworks and characteristics that make it quick to create and easy to implement. But that has downsides because you can go through and test those characteristics, those feature sets, remotely in a user's web browser using JavaScript. So if we can identify that information, that's way more powerful than just simply looking at user agent. So let's do some custom resource detection. All right. We're going to try and detect collusion. Hey, there it is. Collusion was detected. And what I'm doing here, there's this Chrome extension URL that's being generated, and I can go ahead and try and load content based on it and test whether that successfully loads or not. See, there's kind of this restriction on same origin policy that applies, which is a very core browser concept that says you can request information and embed it on your web page from a third-party site, but depending on the characteristics of it, you can't interact with it. You know, it's basically to prevent malicious content from being directly embedded on your page. But there's a very subtle distinction there is when you request like script content, JavaScript content, and execute it, it's actually running it within the context of the first-party site. So we're just loading this up as script and detecting if there's a script error that occurs, and we can say, oh yes, it's detected. Let's do the same thing with Firefox. And I do not have collusion installed. Okay, not detected. Great. Let's install it real quick here. Yes. There it's detected. Same thing. This time I'm using the resource reference that's generated by the Jetpack SDK. And this is basically the API ID that's assigned to the collusion plugin, and then it mangles it with @jetpack and some other garbage. And resources can be loaded externally from untrusted content. So once again, another way to further identify users based on installed extensions and add-ons. And you can also go through and enumerate all of the possible contents and develop vast list of all the different resources that are exposed, and especially if it's a Jetpack-based one based on the SDK information. So active fingerprinting with plugins. Plugins expose their own additional APIs on top of what JavaScript has, and these can get very deep into the browser, into your operating system. So we can pull back detailed system information, fonts, and look at other installed plugins. So I'm going to show an example of using Adobe Acrobat PDF plugin to enumerate some data. So this is downloading a PDF from my site and pulls this data back. Now this is being externally retrieved. So I'm embedding this tracking identifier. You can see environment information, the plugins that Adobe has. And if we scroll down, we start to see information about Flash, Windows Media, and finally the list of printers. So like if you had a computer with networked printers, you would see those list of printers here. Basically, remote sites on the internet can list your printers, your local printers. I think that's pretty interesting. That's pretty powerful. And go back here. So tracking. The goal of tracking is essentially just to install some sort of persistent tracking identifier. And I want to be able to use this to correlate user activity over time. If people are familiar with the ever cookie concept, which was basically to take and store stuff all over and then regenerate it, kind of this zombie cookie idea. Well, I don't think that's a really a good approach. I would rather say, I'm going to store what I can when I can store it and correlate it later. So maybe you have data that's stored for a long period of time, and then you can take and say, oh, well, I saw this data, I saw this ID, and now I can correlate the two. And another thing is to think of, well, this doesn't have to be transmitted on every request. I can wait and transmit it when it's convenient. And finally, you want to have redundancy across different storage types. Some browsers offer more storage features than others. So obviously the basic mechanism is through browser cookies. And kind of the breakdown there is first-party cookies. So you go to a site, installs your first-party cookie, it tracks you. There's this idea of second-party, which is pages that dynamically generate cookies through JavaScript and install those. And finally, third-party, which is you have content, it requests something from a third-party site, and a cookie is installed from that third party. Now, there are certain limitations around browsers, like Safari has a restriction on you have to visit those third-party sites before they can set a cookie, but once you visit them, you can always get that cookie. HTML5 storage, there's way divergent support across these different platforms. Local storage is the best supported of everything. Most modern browsers have some form of local storage, but IndexedDB and the file system API are more modern developments, but support varies. And one of the problems with some of these storage mechanisms is the users have to opt in. They have to choose, hey, I want to let you store stuff. And if you're trying to track somebody fairly quietly, you don't want to have them having to opt into your tracking mechanism. And another consideration is how long does the storage last? Like for the file system API, you can say, well, give me temporary data storage. And that's going to last until it runs out of space on the user's machine, and then the information will be flushed. So the browser cache is another place to store identifiers. The best and most efficient way I've determined is to store it directly in the content. I know there's a lot of talk about using e-tag references, and there have been people that have actually deployed this in the wild, but embedding the content in cache and setting a far future expiration date will keep it in your browser. You can use e-tags then in addition to making it so that when requests to refresh that content are made, and you can control that through the cache control headers, like must revalidate, then you can correlate those values, because perhaps that e-tag is modified or changed based on what the content is, or maybe you're doing versioning, so you want to have versioning information in that e-tag. There are also some very complicated approaches which involve redirects through multiple DNS entries, and then using like DNS caching to say, oh, well, I can time how long it took to do that request, so I know that they went through something that had been DNS cached. Embedded basic authentication references, those are very fragile techniques, and it's hard to get good browser support across those, and it's very limited to the specific browser. So plugins offer their own storage. So these are very powerful because they're cross-browser, and many of them aren't fully integrated with the browser private modes. Back several years ago, none of them were. So you could store like flash cookies, and when you went into like launched incognito or private browsing, those flash cookies could still be read and written. But a lot of work has been done by vendors to integrate these into the private browsing mode so that you're protected. But there are still some left, and they still work fairly well. And another interesting thing about these is these can be very difficult for users to detect, because there's not like an obvious way for them to see that. And some of these demos I'm doing here are, I'll be perfectly honest, they're not real world examples of how you would do this, because I want to show you this information that I'm collecting. If it was just like a server up here running and you didn't see anything, it would be very uninteresting for you. So Flash, local shared objects, those are very popular. That's what everybody says, oh, Flash cookies. I'm talking about local shared objects. There's also a remote shared object. It's a different variation, and it's actually stored in a different location. So if you have code written looking specifically for your LSOs, and they're looking for .sol, they're not going to find .sor, which is where the remote objects are stored, when you provide the optional cache this information locally. Normally, remote objects are used to like implement chat servers or something on the internet. And Flash is well integrated with the private browsing modes, so when you enter and exit those, the Flash cookies are isolated, so they're not readable or written. And that applies both for the local and remote shared objects. And cross-browser support is diverging. If people are familiar with Chrome and the Pepper Flash API that's been implemented, those are stored separately, so you no longer have this cross-browser readability, linkability. So if you have Firefox open and Chrome on Linux 64-bit, they're going to be storing those shared objects in different locations. So the first example is the traditional, MapRemedia Flash Player shared objects. Then there's config Google Chrome default Pepper Data Shockwave Flash Writable Root shared objects, which is a mouthful. So let's look at these real quickly. Pull this up in IE. Okay, so there's my track ID that I've calculated, and this is being done through a remote shared object, cached locally. So if I come over here, back to Firefox. Get this out of the way. I know. Open it up. You're going to see the same value. What is that? Decide later. Get out of here. Yeah. Okay. So that's the remote shared object. And there's this Firefox extension add-on called Better Privacy, and that was like one of the early ones that started dumping your Flash cookies. And if we install that here real quick, we're going to see that it detects LSOs and then deletes them, but it is not going to detect this guy here. So if I close the browser, when it closes, it would say, oh, if this was an LSO, it'll delete it. Yes. Okay. I see you have one LSO cookie I'm going to remove. Okay. But if we come back and look at that, that's still there. That cookie's still, that tracking identifier is still being stored locally. And you know, obviously that matches up with the one in IE. Those are the same. And these are really long because what I ended up doing was saying part of the problem with the current implementations are you can't verify these tracking IDs, so I append an HMAC value to the end of it. So that when I generate it on my server, I know that any values I get back have to be valid or I'm going to just dump them. That way it keeps people from poisoning your tracking identification information. Silverlight. I guess Silverlight's still around. It does work. It has isolated storage, and that's implemented by the Silverlight runtime. And it's localized to your application user, and there's a limited amount of data that's stored there. I looked at using Zap loading to try and cache information, but those are cached by the browser. So it's pretty limited on the information that you can store in there. And there's some other features called satellites and on-demand loading, and those seem to offer limited benefit as well. And there is decent cross-browser support when it's installed and enabled. Java is very interesting because it implements its own download cache, completely separate from the browser. So if you can cache values with far future dates, when that applet's downloaded and stored locally, it's never re-requested unless the date expires or it's deleted. And that's not an easy location to find, and you have to go in and delete this information manually. The applets that are downloaded can read directly from these embedded resource streams. So they can embed tracking identifiers within themselves and then use those for a long period of time. And this is not at all integrated with private browsing, so it doesn't work, period. And there's usually excellent cross-browser support, but that's when Java works. And I'll show you some error messages I got, because I did like a fresh install of Windows 7, and this was trying to get Java working in all these different browsers. Just crashed all over the place. Some of these want you to prompt in. Chrome's a little schizophrenic about when it lets Java run automatically and when it doesn't, so. I'm going to demo these, and you'll notice I'm going to demo these using two browsers that I know work. So we're going to come over here and open this up. Java persistent tracking, Firefox. Okay, so we have this red 7908 value. Open up, Opera. See what it says. Once again, 7908, very good. Now let's come back here, and we're going to start private browsing. So normally you'd think, oh, it's everything's cool, they're not going to be able to store any information, read any information, but that's not true. Because if we click on this, we're going to see, oh, there it is, 7908, same value, private browsing, completely bypassed. So when you have Java installed, it's very, very easy for somebody to store a tracking identifier you'd never really know. Because if we come in here and look, there's this, I have a Java shortcut here, but usually you have to dig into the control panel. It's probably going to be hard to see, but if you look in temporary internet files, which is its own separate location, there it is, tracker, loaded from my demo site here. And that expires, and I just set it for 1 year just for testing, but you could set it for 50 years or whatever it supports. Adobe Acrobat, it has its own persistent storage mechanism for global values called set persistent. So when that runs, you can go ahead and store a value. It's very simple name value pairs, but obviously that's good enough for us because we're just going to be storing these fairly long but not complicated numbers. And there's some kind of mixed integration with private browsing modes, and I think it has to do with when this global data gets flushed out to disk. Because it seems like it gets overwritten, and if you switch into private browsing mode, it just gets kind of corrupted. So it's questionable. And the other thing is that browsers are moving to their own native PDF displays, so this probably won't be around for long, but I mean, there's still a pretty large install base of Adobe Acrobat. Let's go ahead and leave private browsing mode. Same value. So let's pull this up in IE. And this is the same, we did this earlier with Firefox. And we're going to go ahead and see the same value come up. There's this tracking ID that I've installed in Internet Explorer. And then there's the stored one, 7908, that's being stored locally, set before in Firefox. Once again, same detailed information. So that's very, very powerful to be able to pull all that out. There's other storage mechanisms available, such as the user data, which is an Internet Explorer specific value. Web SQL database was going to be the database using SQLite, but that's kind of fallen by the wayside. But there's still, I think, pretty decent implementation, especially within Safari. So that is something definitely to consider when you're building tracking. So unmasking. Unmasking is techniques to try and determine a user's real IP address. Because some people want to hide their IP address, especially like if they're, you could call them bad actors. And your definition of bad actor may vary depending on who you're talking about, because it may be some bad guy on the internet, or it could be somebody that you don't really like very much. And there's many ways to do this. Network proxies, VPN tunnels, just very simple web CGI proxies. So what we want to try and do is force a direct connection, bypass that proxy. And we have lots of options to do that, especially if we can then correlate that with additional information. So there's a few things that we want to do. We want to detect known proxies. If a user's using a proxy, we can probably categorize them as a certain type of person, whether if it's Tor, they're one type of user. Maybe they're using a web proxy to attack your website. So if you can say, oh, I see that they're using a web proxy, is that malicious intent? And there's lots of ways to do that. One of them is to request magic URLs. These proxies implement their own internal URL structure to provide support for the users that are using the proxies, especially ones that are local browser proxies. Network proxies as well, like Squid, it has its own internal URL structure that you can request remotely, and read the responses back. And using XML HTTP requests, especially for anything that's same origin, is very good. Another way is to use, as we saw before, which was embedded script to, try and generate an error or load script content to see did it successfully load. WebSockets are another option. There's kind of limited proxy support for WebSockets currently. So if you can say, oh, I should be able to make a WebSockets request, but I can't, perhaps there's a proxy in the middle. So let's look at some proxy detection. Do Chrome, and I'm trying to mix up the browsers that I use so you don't feel like I'm picking on one, because this stuff works everywhere. So what I did is I requested this HTTP burp 0/0, which is, as I said, I'm going through burp. If you ever looked at that, it's like a list of websites that you visited. So I'm loading that content, getting an error back from JavaScript and saying, oh, I see you have burp installed, because I wouldn't get no error if you didn't have burp installed, because it would say burp isn't a valid domain name, and nothing would happen. And we're going to do that in IE, just so you see it works there. Yep. Detected. So all of this is kind of just, basic information gathering about the user and the type of environment that they have. What we want to do is move beyond that to like proxy bypasses, so that we can use built-in functionality of the plugin content or browser features that will bypass the proxy. And so I've been kind of watching this content site policy for a while, because there used to be this limitation that it had to be same origin or TLD +1 for reports. And if you're not familiar with it, they've changed, the working draft has changed how that functionality is, and Chrome has implemented it. I think I'm still waiting for Firefox, but basically you can send those reports anywhere. So in a CGI style proxy, that's just the one where you go to some website like Hide My Ass, or I don't want to pick on anybody specific, but it's where you punch it in on a website. You don't have a network device or network socket running. So then you go there and it rewrites all the content and displays it back to you. And it's very simple, but it has to rewrite everything. If it misses anything, then you can use those content requests to go and find out about the user's true IP address. And if these CGI style proxies don't rewrite the header content, because content site policy is transmitted in header information, then you can send these report URLs and they will bypass the user's proxy. And I would love to do a demo, but given all the problems I've had, I'm not going to try and connect to the internet and do one live. If I have time at the end, I'll do it. So you can see it works. Plugins and proxies. Plugins have a very complicated relationship with proxies, depending on if it's set at the operating system layer, if it's configured in your web browser. Some proxies can be bypassed directly. Others are controlled when you create the connection requests. So there's lots of DNS leakage is a big problem, because these proxies do DNS lookups. Unless they're SOX aware, they're going to do the DNS lookup themselves. And media requests, or many of them don't respect your host machine settings, so you can go ahead and bypass that information and make a direct connection. And unless you have set up some sort of local firewall, egress firewall that restricts all of this, that information is going to get through. And even at a minimum, let's say DNS, that would be, if not your machine, it would be your host ISP machine that's probably doing the resolution, unless you're like using Google DNS. So that's a another good way to kind of categorize users. And some plugins have direct ability to bypass this using binary socket protocols. You can implement those in Flash, Silverlight, and Java. So let's look at this Flash RTMP connection. And I'm going to use Opera. And once again, this is loading up that remote object. We've seen this before. But what I want to focus on is this connection here that I made out to this track ID. It failed because I don't have the RTMP service implemented yet, but it still makes the connection. We come over and look. We probably have all sorts of junk in here, but yes, there's actually this connection right here. And my fake RMTP server got a direct connection and bypassed that proxy that we're running through that burp proxy. It bypassed that and made a direct connection. So what are some more aggressive approaches? And these are kind of the things that you do when you detect like a really malicious person or a bad actor, because they're really a direct violation of users' privacy. So you could do things like capture keystrokes as they type. I'm sure you've seen demos of cross-site scripting stuff that does this. But if you had a local proxy, transparent proxy that was injecting that content into responses, you could do that for your entire environment if you were in like a corporate environment. So you wouldn't ever have to see even data sent over secure connections if you could poison JavaScript files that got included. You could do more social type attacks, monitoring clicks and likes on social network badges. Do port scanning to local machines in the local network. Java is very good for that. There's some very interesting, technologies around. Can you enumerate locally bound ports? And then obviously just embed additional exploits. But that's pretty mean. So what are some complications to all this? Because private browsing modes, those do work pretty well most of the time. Cookies should not be persisted when you enter and exit your private browsing mode, and content that's read or stored from existing cache shouldn't be available. So that's kind of the user's expectation. So how can we defeat these? Well, if possible, we should correlate the cookie and page contents when it's switching from one to the other, and use plugin support to enable cross-browser communications and correlate those values and cross-reference them. So let's see, Safari private browsing. So Safari, and maybe I will say, like, why do you hate Safari? Let's see, that's not the right one. There we go. I've got bigger for you guys. So Safari is much different in its private browsing mode implementation than all the other browsers, and it doesn't launch a new session for you. All it does is it says, I'm going to dump your cookie jar, and I'm not going to record any content that added to cache. So it's much different than all the other ones, you know, that like incognito mode that's going to launch a completely separate browser instance, completely clean session. Firefox is even better because it launches only a new private browsing mode. So let's go ahead and try this out. So we have this cookie here that we've set. Now, your user expectation when you say private browsing, okay, your private browsing history is private. Okay, yeah, sure. Well, what I did is I have JavaScript running on that page that says, oh, when I see your cookie jar is cleared, I just repopulate that information in there. That's it. And it doesn't clear history, so you can do like history modifications using push state. You can track people through these things. It's almost, I wouldn't want to say it's fake, but it just doesn't seem real. So just something to be aware of. My favorite, local connections. So local connections are implemented in both Flash and Silverlight. And let's get back here. Get out of private browsing mode, yes. Oh, and by the way, I could also have implemented that same technique in private. I should try that. Let's really tempt the demo gods here. In private browsing mode. Wait, before I do that, I'm going to stop. I'm going to stop watching. Stopped. Okay. Start private browsing mode. Yes. Okay, I got a new cookie. Let's start it and see if when we switch out. So yeah, that cookie got persisted from private browsing mode back out. That's pretty scary. So anyway, back to our plugins. Flash and Silverlight have local connections. And these are designed to, allow communication. I want, stop. That is not what I wanted. I just wanted like a little bit, not a lot. So these are designed to allow your communications between, like in the case of Flash, between your Flash applet and an Air application running locally. That's the concept. But what actually happens is it can communicate between your Flash applet and your Flash applet in your private browsing mode, or maybe in another browser completely. So let's try that out. So I'm going to do this send. Okay. Oh, there's our old tracking identifier. That's pretty cool. Let's go ahead and switch over to private browsing mode in Firefox. And now if we do a receive, that's going to go ahead and do a connect, and it's going to start listening. And this send is beaconing out these values. So we can come over here and start listening here. Oh, there it is too. Well, what about Chrome? Oh, I bet it works too. Chrome's a little complicated because when it's separate, when it's using the Pepperflash API versus the other one, it doesn't seem like the communications work properly. So if you're in that situation, you can still do it, still track from incognito, or from a regular browsing session and incognito. Because if we come over and we do open a new incognito window, it's going to be the same thing. So once again, beaconing between browsers, sharing a tracking identifier. And then once you do this, like in a real world example, you wouldn't display it to the user. You'd correlate this by sending it off to a website. And that way then, if a user had said, oh, well, I'm only going to use Internet Explorer for sensitive personal financial information, I'm going to use Firefox and private browsing for other stuff, thinking that they can have separate profiles, you could use this then to cross-reference and correlate those two sets of activities. If they were coming to your website, or if it was like in a more networked environment where you were tracking everything all the time. So I think that's pretty cool. I mean, I don't know. Did you expect your browsers to be able to communicate? I mean, really? Okay. It surprised me. And Silverlight, same thing. So we'll set up this receiver. Come over here. Oh. I'm not even keeping track of these. Send. What are we going to get? Yep, there we go. So you can see that these guys can communicate. Once again, two browsers communicating. You can do this through private browsing or not private browsing. It doesn't make any difference. Internet Explorer has this interesting concept called tracking protection lists. And these are basically maintained by third parties, and they come up with this big, long blacklist of sites to block. And this restricts the content loaded on page, the idea being that you can prevent people from tracking you if they can never display their content. But there's two really big ways to defeat this. The first being you can always manually navigate a user's web browser to a third-party site. You just can't. So if you can manually navigate their browser to that site, and that site coordinates with your site, well, then you can do whatever you want. So let's say I'm going to send them to an advertising site, display the ad there, and then come back. Well, that advertising site can install any tracking identifiers, cookies, whatever that it wants. And then you can also use plugins to load content from blocked locations. You could either do it through like a bootstrapped approach where you had your first-party site, could have a Shockwave flash file loaded, and you could do binary communications. Or it appears in all my testing that you can do it from third-party sites as well. And I'm going to go ahead and demo that here. So basically these tracking protection lists, I'll get in the right web browser, are very simple text files. And I'm trying to block this whole domain, this third-party.example and tracker.third-party example, to say you can't load any content. So you have to install these manually. And this is also the way that in IE9 do not track is implemented. I'm going to add this list. Okay, awesome. Now let's go actually see what happens if I try and reference this third-party site. Okay, there's some content that got blocked. I have this iframe up here. I have an image, and you can see there's that little blue marquee thing on there. But I loaded this Flash content, once again, a remote tracking guy, directly from that third-party site, completely bypassing any of the protections that it appears to offer. So if we look, we can see that network traffic. I'm sorry, this is probably small. Reload this page. And you can see that these third-party examples down here are getting blocked. They're aborted. The connections are never made. But if we look down at the bottom, this Flash guy there is loaded. So, I don't know. Third-party cookie restrictions, those are pretty interesting. Safari was the big one. I'm sure you've heard about Google having to pay like a couple $1 million or $22 million or some crazy thing. They bypass the Safari protections. But once again, you can use the known workarounds, which is to simulate user activity, like navigate their browser to that site and then go back. That'll set the cookie. And another way to do it is to use cross-domain post message to pass the cookies and then store that information in local storage. And I don't know if anybody here uses Stack Overflow or not, but that's their authentication mechanism. Their single sign-on mechanism is based on that concept, completely getting away from cookies and storing it only in local storage and using post message to coordinate. You can also augment that by storing cookies first party from that site. So let's see if this works. Safari. Now you should see this third-party example says this stuff, and I'm sorry I can't make that bigger. And local tracking ID is null. Let's try and load this page again. Okay, and that's all been populated and stored. And this is once again coming from that third-party site. So that should be restricted. There should be no reason that they could store that information, but you can. Do not track. I would describe that as probably one of the biggest practical jokes played on anybody. I mean, if you had to describe that to your mom, you'd say, she asks you what's it do, you say it does nothing. You're asking people that want to track you not to track you. It's like pretty please, and that's why I always call it the don't track me bro header, because that's basically what it is. Don't track me bro, that's all you get. There's no technical restrictions. I mean, it's just, and the protocols that aren't HTTP, you know, it gets sent in an HTTP header, so I don't think they're going to go retrofit FTP with do not track. That's just not going to happen. So finally, tracking server. That's what I've been working on, and all of these demos, and these are just demos that you've seen here, and I did that specifically because it's impossible to have anything interesting to show if it's just like a web service. But basically what I want to do is create a suitable environment to track web users, and I want to give this to people so they can deploy it and do it. And the approach I took was to be as insecure and open as possible, which means if you actually do this, you don't ever want to do this on your like a real first-party domain site, because it will respond to any requests and it'll expose any data that it's stored within the context of the user session. So here are some existing sites, and basically what I've done is taken my own research and I'm going through these and I'm going to implement what works from them and what doesn't, because they have a lot of drawbacks. The Metasploit decloaking engine was for a time probably the best way to do some of this stuff, especially unmasking, but it had an API approach to it. But since Rapid7 acquired them, it's kind of fallen on hard times. I think the wildcard DNS domain that it used doesn't work anymore, stuff like that. And part of the problem with some of these existing sites is you're really trusting them, if they do offer any sort of storage, to store your data for you. And that's just like a bad idea. You don't really have any idea of how the formats are stored, how comprehensive they are, and some of the features, like what you've seen here today, are a little more than proof of concept. But my big push is to move beyond that. So I designed this with correlation in mind. The tracking tokens are probably going to be cleared over time, so you want to have the ability to correlate easily. And your fingerprinting may not yield unique results. So you want to be able to collect and cross-reference all the collected data. And the larger your network view, the more effective this would be. So like if you had multiple sites and you could install this reference to one centralized third-party tracking server on the internet, you could have a lot of data collected. Which is, if you think about what search engines do that have social media empires as well, it kind of all comes together that they can do this and you would never know, because they don't have to be third parties, they can all be first parties. You know, your first party cookie, if those people decided instead of transmitting it to a third party to do all the correlation on the back end, that'd probably be really expensive, but if you had fast networks and, you know, big data centers, you probably could do that. So the methods to inject the web tracking code are pretty standard stuff. You can either embed it like in code on your website, or if you want to do like a transparent network proxy to do like an entire network, you can do that as well. And so as far as protocol support, you can't just stand up like a web server and hope this stuff works, because there's a lot of interrelated features and functionality that would allow you to, you know, like do DNS queries to find out people's IP addresses. You know, FTP, you really want to have that tightly integrated. Obviously HTTP and HTTPS. Policy servers, so you can do your binary connections. You know, you don't want to just be dependent on hoping it works, being same origin or something. Binary sockets, the ability to transmit binary data. Media, like the RTMP that we saw. So what I'm putting out there is basically an ELF release. I'm, you know, going through and trying to find the best ways to do this. So there's going to be some bumps and bruises along the way. I've changed the database format a couple times already, and you know, it's just trying to come up with a way to do it efficiently and effectively is my main goal. And there's many features missing, and I'm, you know, implementing them as I go along. But there's a lot of really strong data that I've already been able to collect. Like that PDF example, that's actually getting sent there, and I'm just echoing it back for demo purposes. Normally, all that fingerprint information would be stored in the database, and then you could try and correlate that later on. So final thoughts. Basically, this web tracking is inevitable. It's going to happen. So why not join the party and do it yourself? You know, what's the worst that happens, right? Well, you probably should talk to your lawyers first. And it's basically impractical to prevent web tracking between coordinating sites currently. You can't do it. I mean, based on the current browser technologies, the people that offer you tools that are supposed to block this stuff are tracking you as well, or they're mining your data that you're collecting and selling it. So you just be aware. And due to technical difficulties, ran out of time for questions. Sorry about that. There's my email address. Send your feature requests and hate mail there, because I will get hate mail. I know I will. Somebody's going to say, why do you hate privacy? Why do you hate freedom? They will do it. And finally, most importantly, fill out the feedback forms. See, the great thing about waiting till the end to tell people to fill out the feedback forms is if they leave, they think it sucks, they forget to fill out the feedback form. So that's it, guys.